Hello. Hi, everybody. Good evening. All right. Okay, so I hope you can see my screen now.
Yes.
All right, perfect. So just as before, welcome everybody to the third live session of the course Foundations of Our Software. And basically what we're going to be doing here is have a recap of what was discussed in this week. And we will take a look at, so since it's basically a coding course, so we'll spend most of our time discussing these commands. And then we will also practice some questions which will be very similar to what you have in your assignment for this week. So that will help you get an idea of what you are, how to solve those. And if you have any questions along the way or even before we begin, please feel free to unmute yourselves or write it in the chat. In the chat. At the end, I suppose we will have enough time. So we will also take a look at the solutions of the last 2 weeks. And if there's any confusion in any of those, we can take a look at that. Okay. So do you have anything to ask or tell before we start the session?
Madam, is it audible?
Yes, I can hear you.
Yes, madam. Just one doubt. You
Yes.
can clarify after some time also.
Hmm.
When we are writing continuous program in 2-3 lines continuously,
Hmm.
some error message. How to terminate that program in each and every line? Please explain.
Okay. All right. Yeah. So let's talk about it when we are using the script, right? Okay. All right, fine. So as I had mentioned in the last week, so all the commands that are discussed in the recorded lectures, they are shown to you on the R console, and I will be showing you very similar commands on our studio. They both work the same way. Our studio is a little more user friendly, that's all. So it's a matter of preference which one of the two you want. So you can install both, but at least you have to install R to um go through, like, to practice alongside this course. So this is just again the same slides as before about installing R, and this is what R Studio looks like. So let's dive right into the practice commands for today. So, all right. So just this is something that we had talked about last week also. We have not used that absolutely up until now, but in the coming few weeks, we will discuss them in more detail. So do remember that there is a concept of working directory, and in our studio, you can directly see what your working directory is. So basically, let's say if this is my folder here, right? So this is how I have. So I have a folder which is made for NPTEL 2024 July, and within that, I have a folder named of this particular course, and within this, I have one folder for each of the weeks, right? So for this week, I have a folder which has my PPT and the R script that we are taking a look at today. Now, this means that if suppose there is another file, let's say there's an Excel file that I want to read, I want to import that into Excel, R here can directly see things which are in this folder, right? For everything else, you need to tell it that, okay, you need to go there, go a folder back, go to a different folder, and so on. So I had it written here, but maybe we don't need to discuss that right now. We'll come to it as and when it comes in the next few weeks. But it's just a good thing to keep in mind. Okay. And last week we had also discussed that if you have scalar, so scalar is basically a single value, whether it's a numeric value or it's a character value. A single value is called a scalar. And if you have multiple values, one after the other, we call it a vector. And the best or the easiest way to create a vector is through this C or combine function. So again, what is a function in R? Anything that is a word followed by the curved brackets. That is a command or a function. I shouldn't say command, that's a function. So this is the combine function. And each function can accept one or more inputs or one or more arguments. And we will talk about that in more detail today. All right. So when you have a single element, versus a single element, you can do calculations. It's a simple, say something like you normally do in a calculator, right? 2 plus 3, 5 to the power 8, and so on. And you can also do a scalar and vector calculation. So that is going to be when you have a vector, when you have, let's say, this vector, and you want to add 4 to each of the elements, or you want to subtract 5 from each of the elements, right? So the same thing is done to each thing. So that's a scalar and vector, like scalar with vector calculation. Now, this week, we start off with discussing vector-vector calculations, and it's also building up on the same idea. So let's say you have these two vectors. I'm defining both of them using the C function, and I'm using the assignment operator to assign this to the variable X and to the variable Y. Okay, so this notation should be intuitive to you now, but if not, practice a bit more, and but you can always replace this with an is equal to sign. Okay, so it's the same thing. So I'm running this command, so I'm just running using command enter here. So I'm running this. You can see here I get that there's a variable X. It has 6 elements, right? Numeric type elements 1 through 6. And I run this one. This also has 6 elements. This is just, again, random set of elements that I've just arbitrarily given. Now, if you want to pick one or more elements from these vectors, you do that using the square bracket. Okay, so the square bracket is always associated with positions. Now I want to take the second element of my vector y. So I can, if I do this, you can see that it takes the second element, which is minus 81. So I get the value of z as minus 81. I could also do it through the is equal to sign. And you can see here that any spaces before or after the operators, it does not matter. It is, again, up to you if you want to, if it's just for clarity's sake. Okay, how readable you want the code to look. Okay, now if I do a vector addition, I add up x and y. I get, so since I'm not assigning the output anywhere, it's just going to give me the output here in the console. So I get the console, so I get the output. So it's going to be adding 1 and minus 100. So I get minus 99, adding 2 and minus 81. So that's minus 79 and so on, right? So both the vectors had the same length. So it's quite intuitive how it's going to go. Now, let's say we have two more vectors, A and B. A has 3 elements and B has 4 elements. Now, if I add A to X, so which has 3 elements and 6 elements, what's going to happen is, so 1 gets added to 10, 2 gets added to 20, 3 gets added to 30, and then this 10, 20, 30 gets repeated. So 4 gets added to 10, 5 gets added to 20, and 6 gets added to 30, right? So different lengths, but the longer length, which is 6 in this case, is a multiple of the shorter length, which is 3 in this case. So we still get the output, and there's no error or no warning message. However, if I add X with B, so it has 6 elements and 4 elements. So again, the first 4 elements are okay. 10 plus 1, 20 plus 2, 30 plus 3, 40 plus 4. And then it starts repeating. So 10 plus 5, 20 plus 6. But then it's not able to complete that second round of repetition, right? So because the shorter length, the longer length is not a multiple. So what it does, it would still give me an output, and the output is correct, but it gives me a warning that double check if this is what you actually wanted, right? Or if this is just something that, you did not take care of and now have different lens, but were you expecting same lens or something like that? Okay. And yeah, I don't know why I have this here. Okay. Yeah. So just keep in mind, the basic difference between a warning and an error message in R is that when you get an error message, you don't get an output. The command does not run. Okay. But when you get a warning message, you do get an output, but you need to check to be sure if the output is correct, or if it's just, the inputs were not what you were thinking of the inputs to be. Okay. But that's that. And just like we did addition here, you can also do subtraction, multiplication, division. So just keep in mind that when you have two vectors, it happens element wise. For those of you, so I think, yeah, most of you might have had physics in 11th and 12th. So you remember there is a different thing how vectors behave in physics. But that's not what we are dealing with here. Okay, this vector is just a sequence of numbers, right? Okay. Also, since we're talking about these mathematical operators, there is one more very common mathematical operator, which is power or, yeah, power or exponent. So typically you would have seen the caret symbol, which is on the keyboard above number 6. That's used as a power sign, but double asterisk can also be used for the same thing, right? So if this gives us 1000, this command also gives us 1000. So it's the same thing. So just for a quick revision, if a power is in negative, this means that you are basically doing a 1 upon that number and then the power. So this effectively becomes 1 by 10 whole to the power 2. So that's 1 by 100. So that's why you get 0.01. And 0.6, you can also have a decimal or a point power. So it's basically if the power would have been 0.5, then it means that you're taking the square root of a number and so on. Okay. And if you take a vector and you power it, then of course, so if you remember, x was 1, 2, 3, 4, 5, 6. So you take the cube of each of these elements. So that's good. What is this command going to do? 2 to the power x.
It's ma'am, maybe like a 2 ki power x, like if we have a vector
Mm.
x is 10, 20, 30, so it will
Mhm.
calculate like 2
So,
ki
so
power
this
10,
is
2 ki power
x.
20.
Yep,
Yeah,
perfect. So if x is this number here, 1, 2, 3, 4, 5, 6. So it's going to be 2 to the power 1, 2 to the power 2, so on until 2 to the power 6. Right? So
yes,
that's
yes.
correct. Okay, so that's also, so you can have number to a power of vector, or you can have vector to a power of a number, and you can also have vector to a vector, right? So now this is, again, it's not something you might need it very often, but again, what this is going to do is also do the calculation element wise. So the first element of x raised to the power of the first element of y, second element of x raised to the power of second element of y, and so on. Okay, you can double check by you doing these individual calculations, but that's how this is. Okay, so these are the basic arithmetic functions. There are two more arithmetic functions that we will discuss. So I'm not sure what this was called, but you would have definitely read about this in school. But anyway, so whenever you're doing this long division method and you're not going into decimals, so you
Excuse me,
have
ma'am.
you have a quotient and a remainder, right?
Yeah,
So
excuse me, ma'am. Uh,
yes.
yeah, sorry to interrupt. Here we are dealing with the one, like one column, not one column, one row.
Huh.
So if we want to create a square matrix or maybe 3 into 2 or 2 into 3, how
Mm-hmm.
we can create that matrix?
Okay, so we will come to it. So matrix is there. So wait for 10-15 minutes and we'll come to matrix here. The third part for
Okay,
today's
okay,
matrices. Okay,
all right,
all right,
all
yeah.
right.
Okay, so yes, so when you are dividing a number by another number, you get a quotient and you get a remainder, right? So that is when you are not interested in the decimal value, but when you want integer values. So the sign to do that in R is that, so you have this percent slash, so it's the forward slash, so percent forward slash percent, that gives you the quotient. And if you just write 2% symbols, you'll get remainder. Okay. So for example, when you're dividing 9 by 2, you'll get 1 as the remainder and 4 as the quotient, right? So you get 4 as the quotient here and 1 as the remainder, right? So again, this can be useful when you are making, so for example, very simple. Let's say if I want to calculate how many weeks are there in a month. right? Or how many weeks plus days are there in a 31-day month. So what I can do is I can divide 31 by 4, right? Because, I can divide 31 by 7 because I know a week is made up of 7 days. So 31 by 7, I get 4 as a quotient and 3 as the remainder. So I can say a month of 31 days, let's say August, it has 4 weeks plus 3 days, right? So statements like this is where you might use such calculations, such quotient and remainder thing. All right. Okay. So yeah, so this is the actual division sign. So when you're dividing, again, let's leave it again using the vectors here, right? So it's going to go all the way to the decimals. Yep. So you get the decimals here. And then if you are doing these modulo functions, so integer divisions or modulo functions, so you just get the you get the number smaller than the value. So just imagine, so we took two cases, right? When we are dealing with positive numbers, and in this case we are dealing with negative numbers, right? So when I divided 31 by 7, I got 4. So if I would not have continued, I mean, if I would have continued the division, I would have got 4 point something. So I stopped at the integer before 4 point something. So that's 4. So the smallest integer, so the greatest integer smaller than that number, right? So that's 4. And the rest of it was the remainder. And in this case, when I'm dealing with negative numbers, right? So for example, I had 21.3, right? What happened here? Yeah, okay. Interesting. So take a look at this. So when I divide y by x, which is this thing. So let's take the third example. So 64 by 3. So that's giving me 21.33. So minus 22 is so minus 22 is my quotient, right? But or it's not really the quotient, it's the highest integer less than my quotient, less than the actual calculation. And here in this case, it returns, since it's a negative value, it gives me the actual divisor as the remainder. So this, so does this make sense, or is it still confusing? I think it's still confusing, right? Okay, let me double check what is happening here, and maybe I'll get back to you in the next class. Okay. But yeah, okay. But for positive numbers, positive integers, this makes sense. Okay. Okay, all right. Now we have been talking a bit about some functions. So we have seen that C is a function here. We talked about sqrt as one of the functions. Okay. We'll talk about matrix and all of that. So there are lots of more functions which are built in R. So for example, if you want to find the maximum number from a given set of numbers, if you want to find minimum from a given set of numbers, so you just write max, and within bracket you write your vector. So this is important. Within the bracket, what you're doing is you're writing the vector. You're not writing numbers separated by a comma only. So for example, the way it's supposed to work is, if I have x here, right? So max of this x, I should get 6 here, right? And minimum of x, I should get 1. So this is behaving as expected. Now, if you see here, if I just have this example, so I have a set of numbers, which is 1, 2, 3, 4, 5, and 0. I can write them directly within the brackets of max, or I can write them as a vector and then write it inside max. So do you think there would be any difference in the output here, or no? Just you can take a guess. You can put it in the chat. You can unmute yourselves and tell.
Ma'am, what I understand, like if you
Mhm.
are taking max C, so C is represent like a vector,
Yes.
and another one is max of this number.
Yes. Correct. Okay. So it looks very similar, right? So I'm just giving it multiple numbers directly. So basically, the way R will try to read it is that here there was just one input to the function max. That input was a vector, but the input was just one, right? Because if you see within the bracket that is highlighted right now, there is just one input. That whole thing is set up as a vector, right? But in the second case, I have 6 individual inputs to max. So let's take a look at what max actually wants as the input. So the way you can read about any function is you have a question mark and you write the name of that function, and this help thing opens up. Even if you're doing it on console, it's the same thing. A new window is just going to pop open. Okay. So now, all right. So here what it says is that max on min, the other function's min, it will return the maximum minimum of all the values present in their arguments. So it does say arguments or inputs, right? So it's multiple. So when I'm running this one here, irrespective of how I do it, it still gives me the right answer. Okay, which is great. I mean, this is what you would expect. But now let's take another function as the example. So that is mean. Okay, mean, that's the arithmetic mean, right? Or the average. So again, the same thing. If I have x here as my input, so that is 3.5 is the average. So it's correct. Now I do the same thing here. I feed it one input, which is the vector input, or I feed it 6 individual number inputs. And now I see what mean wants as the input. So again, if you see here, so mean is saying that I just want one argument, right? So here I've given it one argument. So it gives me, okay, so the mean of this thing is 3.5. But if I give it 6 individual inputs, what's happening here is saying that the mean is 1, which of course is wrong, right? So can you think what is happening here? Why is the mean for this statement turning out to be 1? What do you think? Any guesses, anybody? No? Okay, all right. So what's happening here is mean just says that I want only one input. So it's taking the first number as the input and it's ignoring everything else. So it's saying that the one that I've highlighted here on line number 68, it's ignoring all of that. And it's only saying I got one input. So I take the average of that input, whatever that, whether it's a number, whether it's a vector, I just need one input. So in line number 67, this whole thing is one input. So it works fine. In line 68, it takes only the first value as the input. Now, this means that the way max function deals with numbers is different from the way mean works with numbers. And it can be confusing to remember which is, which is more correct to do, which one should I use when. So what you need to remember is whenever you have vectors as an input, you always have them as a vector. I mean, if you have multiple numbers, always have them as a vector and then feed it to a function rather than feeding these numbers separately. Okay? So this is just something that you should remember. It's a good practice. Okay? All right. Now again, all right. So I have these few statements here. Okay. What do you think this would be doing? So x, if you remember, x is a vector. X is this 1, 2, 3, 4, 5, 6. Okay. If I write sum x, what is it going to give me? Come on. What do I get if I sum the vector x? I don't need the numerical answer. You can just tell me what's going to happen.
It will add all the elements.
It will add all the elements. Perfect. Simple, right? Okay. So the sum is 21. All right. Now what if I feed it sum x plus y? What is going to happen here? Now these questions are just to give you an idea of how is our understanding inputs, how is our dealing with how you write elements, or how you write variables and how you write commands. So what do you think is happening here? So the idea that you also have always known in the form of BODMAS is that whenever you have brackets, you start off with the bracket which is the innermost, and then you solve the outside thing, right? So again, in R also you do something very similar. If you have a function within a function, you solve the innermost first. So it's often called nested in computation terms, command terms. It's often called nested functions or loops, as we would come later on. But so basically, there's one set of operations happening inside, and then another outside, and then another outside, and so on. Okay. So in this case, there's this bracket. So there is a calculation happening inside the bracket first. So we first deal with that, and then we sum up whatever output we got from there. Okay. So what's x plus y going to give? We saw that before, right? So x plus y, these are two vectors. They both have 6 elements. So if I write x plus y, it's going to give me the element-wise sum of each of the total vectors. And I still get a vector which has 6 elements in it. And then since I'm feeding that output, so I'm feeding this to sum. So basically I'll get a sum of all these numbers. But in short, I've got a sum of 6 numbers and 6 numbers. So in total, the 12 numbers are added. Simple, right? So I get one final answer. Okay, now this is important. What do you think is happening here? Would anybody like to try this? You can unmute yourself and we can go step by step. But it'll be a good practice if you try to understand this on your own. It's okay if it's wrong. No problem.
Ma'am, it's
Yes.
maybe like add vector wise, like elements of first, then second y, x and y. Like x is 1 and y is minus 100, so it will be 99, and
Okay.
then 79.
Let
Like that.
me stop you just there. So we are dealing with this one here first, right?
Mhm.
So inside, I am not adding. So sum is outside. First,
Okay.
let's talk about what is happening here, right? So this is a
Okay.
combine function. So I am combining vector with vector. What do you think that means? I have a 6 element vector. I have another 6 element vector. And I'm saying combine them. So what do I get as the output here?
First output will be some like a 1 comma minus 100.
Okay, that's a good thing. So remember, this is also combined. So basically what I'm doing, I'm combining 6 things one after the other.
Yes.
Now here also I'm combining 2 things one after the other. They themselves have 6 elements.
Yeah.
So what do you think is happening here now? So it's going to be 12 elements. Let me run this again. So you see it's 12 elements. First all the elements of x and then all the elements of y. So in this step, it was not necessary that both of them should have same number of elements. It's just I'm making a new vector here. It's a 12 element vector, right? And then I'm saying sum up these numbers. So when I sum up these numbers, I still get the same answer as I got here. The reason is in both cases, there are 12 numbers at the end which I'm adding. I'm adding them in different orders, but you know, addition is commutative. In whichever order you add, doesn't matter, right? So again, this is just to confuse you and to give you a practice. Okay. Now, what do you think is happening here in line 76? And try and see how it's similar to maybe line 74. So again, we start off with the very inside of it, right? Would anybody like to try? No? Okay, no problem. So the most inside of this was x plus y, right? So we saw x plus y is basically element-wise addition. So you have 6 numbers and you have 6 more numbers, you add them up and you get a new set of 6 numbers. And then if I'm specifically saying combine, right? So this is already combined. I'm combining this with nothing. So I get the same thing as the output. Oopsies, sorry. So this and this, you see it's the same output. So this bracket of C is just extra, but it doesn't harm, right? But I'm very sure now this is a vector that I'm dealing with. And then you sum it up, you still get the same answer. Okay, so all I wanted through this activity was just to give you an idea that there are different ways of getting the same output. It could look something as simple as this. It could look a little more complicated as well. But what you need to try and do from such exercises is that to get an idea of how R is dealing with a particular notation. How is R going to understand? So you manually try to see, okay, and it's adding x plus y first, or it's making a vector and then it's summing up. And then, okay, this is how it should do. And then if you get the same answer from R as well, then you know that, okay, what you understood is correct. Okay. So, yep. All right. So I think the confusing bit is over. Just like there is a sum function, there is also a product function. So you can multiply two vectors. Okay. But now, if you see here, what it actually did was it multiplied all of this and it multiplied the other vector, everything. It just multiplied everything with everything, right? So it's similar to this sum function. So remember, when you have mathematical operators of the plus symbol or the asterisk for multiplication, there you're doing an element-wise thing. But when you have functions which are named, so you have the sum function or the product function, I don't know why I've written this. So when you have the sum or the product function, then you need to remember that it does it for everything. All the values altogether, they'll be multiplied or added. Okay. And again, this is the same thing. You can also find, yeah, okay. So this is not important here. Okay. Yep. So, so product again, you can do it in a different way. Again, you can write C. You can already multiply them and then do a product. That would also give you the same thing because ultimately you are just multiplying everything all together, right? So any sort of a notation here would work. So product is behaving very similarly to sum. Okay. All right. And then very often you might want to find absolute values for a number. So basically, absolute means that if you have a positive number, you get that positive number back. If you have a negative number, you get its positive value back. So without the symbol, right? Again, you can feed it single values. So if I feed absolute 3 or if I feed absolute -3, I get 3 as the output in both cases, right? But if I feed it a vector, it's going to give me the absolute value of each element. So there's no cross element thing happening. This is also element wise. We can have square roots. So square root of positive numbers definitely exists. We know that. It's only going to give you the positive square root. So it's not giving you 2 square roots. It doesn't give you both the signs. And if you do it for a square, if you do it for a negative number, it's going to give me something called NaN. We saw this briefly last time also. So NaN stands for not a number. Okay. R does not handle imaginary numbers by itself. I'm not sure if there is a particular package in R which you can use to work with imaginary numbers. I believe there would be something, but I'm not sure about it. Okay. There's also functions to get log. So if you just write log of a number, by default, the base is going to be E, but you can specify. So if you see here, so for example, so let me open the help of the, the log function here. So you can see here, you can have log. So it accepts one input, which is the main numerical input. And there is another input, which is a named input. So that's called base. And the base is where you can specify what the base should be. Okay. So if you want to specify base as E, which is also the default, then you just write this complicated thing like exp bracket 1. But if you want any other random number as the base, you can write the actual number that you want to calculate the log of, and then you can write base is equal to whatever number it is. So it's log 8 base 10, base 5. For specifically log 10 and log 2, just to make things easier, you don't have to write base is equal to whatever every time. There are other functions which are directly log 10, log 2. Right? So within this, if you write log 10 base 10, so you know log of a number base that same self is going to give you 1. So anything you write here. So that's log 10 base 2. Again, there are lots of different ways of calculating these things. But you can also do log calculations. And here we are taking just scalar values as the example. But it's going to behave the same way if we do it any different way. Right? So if you calculate log of the vector x to the base 4, you've got these values. Okay. All right. And then, of course, you have the exponent function. What happened here? Okay. So what exponent is basically going to do, it's going to give you, I think it's e to the power that value, right? Right, that's what exponent means. Maybe, I'm not sure. I'll have to check. It seemed to have missed this. Okay. Then of course there are more things, like you can also do all trigonometric calculations. So which is sine, anti-sine, and so on. Do give it a try. These are not, again, this is very specific to what field, if you have trigonometric functions in your field. But again, this is just for your information. Okay, now this is something which is a bit more important. Okay, so you are all familiar with rounding off numbers. Okay, there was something called estimation in school. So when you're doing a round off, you can do a round off to the decimal places. So let's say if this is the number that we have, 1.23456, and I say I want to keep 3 digits, right? So that means I want to keep 3 digits after the decimal, and this is what I get. And it's rounding off, so it's going to round off to the nearest. So you know that here, since the number was 5, so it's going to round off to a higher value, right? So which is why 234 becomes 235 in this case. Okay. If I say I want to keep just 1 digit, so it's going to keep just this one. And since the next digit is less than 5, so it's not going to take it to the next higher value. So it's just going to give me 1.2. Okay. If I say I don't want to keep any digits, then it's going to round off to the nearest integer, basically. So 1.98, that's going to be, nearest is going to be 2. Had it been 1.1, so let's say had it been 1.1, then it would have rounded off to 1, right? Because that's the nearest integer. So that's rounding off. You're not truncating, you're not cutting the values, right? So you're not estimating anything, you're truncating something, right? So if it's 1.98, for example, it's just going to give me 1. It's going to cut off the decimal place, and it's just going to give me truncation. Truncation basically means cutting down or stopping somewhere in between. So let's take a few examples here. Yeah. Okay. So you can see this. Yeah. So there are 3 things basically: truncation, floor, and ceiling. So we tried truncation here. So let's try the other 2 as well. So ceiling, as you can see, ceiling is the next highest integer, and floor was the lower integer. Okay. So again, it depends what sort of a code you're writing. Somewhere you might want, if there are decimal values, you always want the next higher number. Sometimes you always want the previous lower number, right? So again, in those cases, you can take a look at truncation, ceiling, and floor. There's one important thing which we should discuss here. That is what would happen if there were negative values. Okay. So if I'm doing a truncation on a negative value, so truncation basically means I am just ignoring the decimal. It doesn't matter if it's a negative number or a positive number, I just ignore the decimal. So I get -1 here. For ceiling, what we do is we get the next higher number, right? So when you have -1.98, the next higher number is -1, right? And when you are talking about floor, the lower number than the lower integer than that was -2. So this is sort of quite intuitive once you understand what these words mean. Truncation is just removing the decimal, ceiling is always the next higher integer, and floor is always the previous lower integer. Okay? Okay, all right. And you can see that this is, there's a little bit of explanation about all of this given here. Okay, and then as we will see in some of the examples today, and you might have already taken a look at the assignment, you can have very complex mathematical setups made through a combination of these operators. Somehow change the value as well. Can you elaborate? I'm not sure if I understood your question. No, I think you'll have to elaborate on this. The value isn't changed. Well, the value will not be changed, right? I mean, the value, you're just removing the decimals. I'm not sure if I've understood your question. Truncation just means you are removing the decimals. That's it. mean, you always have your round of things, right? So it's it's round, truncation, ceiling, floor. So round off will be a lower value or a higher value depending on whether it's less than halfway or more than halfway. Truncation is always going to give you everything except decimals. So it's generally always a shorter number. And ceiling and floor are again higher and lower, irrespective of whether you have positive or negative numbers. I'm not sure if I've answered your question. Let me know. Okay. All right. So that is the operations and operators part. Now we come to something called matrices. Not a lot is left. Okay. So as one of you asked, right now we have been dealing with vectors. So you can imagine them as something in one dimension. Typically, you can call it it's a column or it's a row. It's upon you. It's up to you how you imagine it. A matrix is definitely two-dimensional. So you have rows and you have columns. And one thing to remember, and this is something which is also sort of standard in maths, that you always refer to the row first and then to the column. That's a good, that's how things are. That's what maybe like a syntax is. And if you keep this in mind, it's going to help you. It's going to help you and not get you confused. So you remember we had talked about the square bracket earlier. Where is it? Yeah. So we talked about the square bracket, how within the square bracket, if you give a number, that's going to be the position of some position of that vector, right? Anyway, so we'll come to it in a while. Now matrix, that's the name of the function. So you have bracket, and within matrix, there you can have 4 arguments. Each of them have a name. So it's good if you can remember the name, but there is another way to simplify things. So the first argument is data, where you actually specify what values are going to be there in your matrix. And definitely the values that you give, it's a group of values, right? Which currently don't have a shape of 2 by 3 or whatever, x by y. So you just give them as a vector. So here I'm feeding it 6 values. A vector has 6 elements. And I say the next argument here is n row, which stands for number of rows. So I say n row is equal to 3. The argument after that is n call is equal to 2. So 3 into 2, that's 6. So that's something you have to keep in mind, that the number of elements in your vector should be the same as should the product of the number of rows and number of columns. And then, so maybe I can draw this here. So if you have so I said, here we said that we have 3 rows and 2 columns. So it's going to be 1, 2, oh, no, wait, sorry. 3 rows and 2 columns, right? So this is how this is. Now I have the option that I can fill it like this. So this is called filling it row-wise, or I can fill it like this. So this is filling it column-wise. Now, if you would have seen here, there is an argument which is called by row. Now this can take values true. So this is by row, or it can take values false, which indirectly means that you're filling it by column. So not by row, it means you're filling it by column. Okay, all right. Okay, so now what's happening here is I have these 6 numbers, 1, 2, 3, 4, 5, 6. So I can either fill them by row or I can fill them by column. Let's try both. So I say by row is true or by row is false. I'm running both of them and I'm saving the matrix to m and n variables. And if I just open these up here, okay. So what you can see here is both of them have the same arrangement, in the sense you can see there are 2 columns and 3 rows, which is what we specified, right? We want 3 rows and 2 columns. Okay. But now in the first case where we filled it by row, the numbers are filled by row. So you have 1, 2 in the first row, then 3, 4, and then 5, 6. But when we are filling it by column, you have 1, 2, 3 as one row, and then 4, 5, 6. Sorry, 1, 2, 3 as the first column, and then 4, 5, 6 as the second column. Now, again, it's not about one being right or not. It's about how you want your data to be filled. Because definitely the two matrices are very different. They look, the size is the same, but the elements are different. If you sum up columns, if you sum up rows, they're going to be very different, right? Now in this example, in the third line, I have not written either of the two things. I've not written if it's true or if it's false to be filled by row. So what does it do? So in these cases, so very often some arguments in R, they have a default value. Okay. Because it's not, so I mean, it has to be one way or the other, right? There's no third option. So here, by row, it says that it's a logical value. So true and false, they are logical values. And false is the default. That means by row is false. So that means it's filled by columns. The matrix is filled by columns. That's the default. So if I write O here, so you can see O looks similar to N. I mean, O is the same as N, right? Because the default argument is false. Now, while having default arguments is good, because then you don't have to remember. But I mean, it's good that there is something, so you have to type less, but in fact, you have to remember what the default was. And sometimes that can be very confusing. So very often, it's up to you. You can always write how to fill it by row or fill it by column. Writing it again is never a problem. Even if there was a default, you've written it, it's all good. Okay. Now, so you saw here, there are these 4 arguments, data, nrow, ncol, and byrow. Now you see this line number 130, for example. I can shuffle up the order of these elements. Since they're named elements, I can write this first. I can write ncol first. I can write nrow later. I can write data after that. I could have also written that maybe, okay, I could have written this somewhere here. Okay. Right? So if I'm writing something like this, can you tell me if my Q matrix should look like M or it should look like N? Which one should it look like? Or it should look like something else. So you can see it runs without any error. So R is able to understand because these were 4 named arguments, right? So you can jumble them around. It's not necessary for you to write it in the same order. So I have 2 columns. I have 3 rows. 3 rows here. I say that by row is going to be true, and I have the same data as before. So is matrix Q going to look like matrix M or like matrix N? Which of the two? M. Perfect, right? Because that's what I had filled like by row was true, right? So yeah, so it's filled by row. So it looks like matrix M here. Perfect. So that's one way to go about it, that you can jumble around elements given that you have named them. But the other way to go about it is you keep the order consistent. You still write data. After that, you write nrow. After that, you write ncol. After that, you write byrow. But you don't give these names. You just give the values. So I have the value for data. I have the value for nrow. I have the value for ncol. And then I have the logical argument true, which goes for byrow. If I run this, then also I get it same as matrix M. But I got away with writing so much less. I do not have to write all of this here. But again, this is important that you need to remember that, okay, data you generally write first. So that's easy to remember. But this 3 and 2 Had you written it opposite, had you written 2 comma 3, then you would have got a matrix which has 2 rows and 3 columns instead, right? So again, it's a matter of preference, whether you want to write the names of the arguments and be carefree about if the order was correct or not, or if you want to not write the names of the arguments, but you're sure that the order that you're following is correct. Okay, so for example, one of my favorite ways to go about it would be, let's say, so you also don't need to write combine function. Maybe you can also do 3, 4, 5, 6, 7, 8, 9, 10, 11. Yeah. So you could have written just this, but since I'm not sure whether ncall comes first or I can do, wait, maybe, and n row is 2, and then by row is false, let's say. So I can do this. So I don't have to write the names of all arguments. I did not write the name of my first argument, which is my data, because I know I'm always going to write my data first. But for the other two, I was not very sure if ncall and nrow is the order or nrow or ncall is the order, right? So I could have written it this way. I could have just written it this way as well, right? Now tell me what would happen if I would have written it this way. What's going to be the output here? What would happen if I run line number 136?
It will be same.
Same as which one? These two?
134. 134.
Okay. So it's correct, right? However, it's just more important. So it's good that it's running. I would have thought it would not have run. But since there is just one logical argument, there's no scope for confusion here. But I would still recommend that be sure of either be consistent with the positions or be consistent with the names. Don't jumble up, okay? Because then it may go wrong. But again, it's if you're sure, if you've practiced enough and you understand how things work, then there's no one right way to do it. Okay, all right, great. Just a few more things about matrices. And so just to remind you, this is the matrix M and this is the matrix N that we'll take as examples for the next few lines. So both of them, now how do I attribute these matrices? So I'll say both of them are 3 by 2 matrices because both of them have 3 rows and both of them have 2 columns. And like we said, generally always rows are referred to first and then you refer to columns. Okay. Now you can see something here. So what this means is if you have a square bracket and you write a comma in that square bracket, you can write a number before the comma and you can write a number after the comma. The number before the comma indicates the row. The number after the comma indicates the column. You can leave before or after the comma is empty. Now, what would happen that way? Okay. Good question. So let me come to that now. Okay, so let's say if I'm saying the data is, let's say, this is the data. And if I say ncall, let's say it's 2, and nrow, let's say, is also 2, right? And let's say by row is going to be true as well. So what's going to happen is it does give me a matrix, right? So I said by row. So 1 and 2 goes in the first row, 3 and 4 go in the next row. And then it says warning. In the matrix, the data length, which you said 9, is not a submultiple or multiple of the number of rows, right? And since we have this question, let's do it the other way. What if our data was smaller? So let's say, what if the data was only 4 elements? And instead, my matrix that I want was of 9 elements. Like it was a 3 by 3 matrix. So then it's something very similar to what we've seen earlier, that the numbers get repeated. So it's 1, 2, 3, 4, then again 1, 2, 3, 4, and then again 1. But I still get a warning message that the data is not a multiple or a submultiple of the number of rows. Okay, but that's a very good question. Thanks for asking. So again, just like what we did in vector calculations, if you are dealing with two vectors, they should ideally be of the same size. Similarly, when you have a matrix, the data and the number of elements in the matrix should be the same. But it can be different. You just have to be careful that the matrix you get is the matrix you were actually intending on getting. Okay, good. All right. So coming back to this thing. So this was the matrix M. So anything I write before the comma refers to rows, and anything I write after the comma refers to columns, right? So when I'm writing comma 1, it means first column. And since I've not written anything before the comma, it means everything, not nothing, everything. So which is why when you refer to the first column, you just write comma 1. So blank comma 1. So everything, which means all the rows, but just the first column. Likewise, this means all the rows, but just the second column. And here it means first row, both columns, second row, both columns, third row, both columns. Now, what do you think this should give me? M, and in square brackets, remember square brackets, 1 comma 2. Which numbers, what should be the output here? What are we doing here?
I'm not sure, ma'am, but it should be 1 cross 2 matrix, like one row and 2 column.
Okay, that's good thinking, but that's incorrect. Would you like to give another try? So the hint that I'll give you is we're talking about elements at a particular position here, right? So you
First
remember.
row, second element.
Okay, then
Yes.
first row,
Second
second
element.
element.
Yes,
Yeah,
yes,
yeah.
perfect. Okay, great. So first row, second element, which is this thing, right? So it should give me 2 as the answer. So it gave me 2 as the answer, right? Again, what about this one? What should be the answer?
5.
Right? Okay. What should be the answer here? I already have the answer written next to it, but anyway. What's happening here?
Third column here, third column is not here, so
Yes.
that's called error. Yeah.
Okay, perfect. Good. So error. So error, whenever you get an error, it means you're not going to get any output. And the error, it says here that subscript is out of bounds. So very often positions are referred to as subscripts. So subscript is out of bounds because it's out of what was actually there in that data. All right. What do you think is happening here? What would I get here? 3 comma nothing.
5 or 6.
5 and 6, both of them. Right? So now what I've got, yes, the whole row. So one whole row of a matrix is actually a vector. So what I've got here, so M3 comma nothing is a vector of the third row of my matrix, this thing. Okay. And likewise, what is this? This thing.
Second column.
Second column also. So that's also a vector, right? 2, 4, 6. And again, like we've been talking about, even if you would have had a space here, even if there was a, what's happening? Sorry. Yeah. So even if there's a space here, it doesn't matter. Space is not a problem when you're working with R. Okay. Maybe we can try one more thing here. So what if I get, okay. a little more complicated now. What do you think is this here? So this refers to the row, this refers to the column. No, we're not going to get a matrix here. Okay, whether or not it's a matrix, what positions are we talking about here? So like before, we're talking about the second column, right?
2 or
Sorry.
6.
Yes,
2 or
perfect.
6.
Perfect, perfect. So we're talking about the second column here. And amongst the rows, we're picking the first and third row. So everything written inside the square bracket is positions. You are not dealing with values here. Inside the bracket, you are only talking about positions. So 1 and 3 is the position. So 1 and 3 is the position of the row or row numbers. So you're talking about first and third row and the second column. So that's this element and this element, 2 and 6. Okay. So again, we get a vector which is made up of 2 elements, and those 2 elements are 2 and 6. All right, good. So I can understand this is a bit complicated, but it's just through practice. So what you can do is make random matrices. Sometimes you'll have more elements, less elements than the number of rows and columns. You'll see some errors, you'll see some warnings, and try to access, okay, if I want the first row, and if I want the third row as well, and if I want the second and fourth column also, how do I write it? You can also get a sub matrix. So just let's take one more example here. So if it was 1, 3, and if I would have written 1, 2. Okay. So just one more thing. Would any of you like to try this? So again, it's the same thing. I'm talking about the first and third row, and I'm talking about the first and second column. So as soon as you have both multiple rows and multiple columns, you're dealing with a matrix. So here I got a submatrix, which is made up of the first and third rows and the first and second, both columns, but I'm missing the second row here. So it's a submatrix. In that case, like the elements of same column 2, can they be represented as a column matrix only? So I'm not sure if there's a concept of column matrix or row matrix in R. Instead, when you have numbers in just one dimension, you call them vectors. There's no, there's no arrangement, whether it's horizontal or vertical. It's just a set of numbers. Does it make sense? It's just a, yeah, okay, all right, perfect. Okay, now if, so there's just one more thing you can do here. So whenever you're dealing with matrices, so you can see here your numbers, which are single numbers or vectors, they've been grouped as values. And these two-dimensional things, they've been grouped as data. And just a plus point of working with RStudio is you can see that here in values, you have a cursor, but here you have a hand icon. So I can click on any one of them and you see it opens here. So it opens up as a two-dimensional object here. We will not talk about this right now because it can get confusing, but you see here, for each of your rows and columns, there's a number written here, and there's some sort of a name written here. Okay, so it's V1, V2, these are column names, and 1, 2, 3 here, these are both row names and row numbers. Okay, we'll talk about this when we come to more types of data sets. But definitely remember that there's something called a column name. You can name each column and you can refer to each column by that name. Okay, but we're not going to talk about it right now. All right, perfect. So suppose you don't have access to, this thing, or maybe sometimes your matrices can be really big. You can have 10,000 by 3,000 something. long matrices. So what if you don't have access to this environment, or what if you don't have access to this sort of an arrangement? So you might want to just take a look at how many dimensions are there, right? So you can just write dimension. And if you remember here, just taken n matrix as the example, but it's again the same thing. It's just arranged differently. But yeah, so if you do dim n, that's 3, 2. So 3 rows and 2 columns. You can also get these values individually. If you just write n row, you get 3. If you write n col, you get you get 2. And if you write length, then you just get the number of elements in that. You can also do length with vectors actually. So number of elements in matrix, and you can also have number of elements in vector. Okay. All right. Now, let's say I have 2 more matrices. This is just the final bit. I'm calling them R and S. Now, one of them, let's say I'm making both of them as character matrices. So you can already see here I'm getting character as the element type. Again, we're talking about 3 rows and 2 columns. So any idea what is happening in these matrices, right? So because we've talked about sum and all, right? Like typically, okay, anyway, so let's not go into this. This is going to come up next week. We'll talk about it then. It's going to get too complicated right now. Okay, anyway, so what I wanted to tell by this is that your matrix can also be character type, right? So whenever you have things in double quotes, each element in double quotes, you can have a character matrix. You can also have mixed type of matrix. So for example, if here we would have had, let's say if it was something like this, I have some numbers as numbers, I have some alphabets, and I have some numbers as character numbers. So basically everything which is in double quotes is a character, irrespective of the thing inside it, if it's number or not. And then I also have some which are actual numbers. So if I run this, you can see that everything is taken as in double quotes, right? Because a mixed vector does not make sense. We saw this last time also. If you have a combination vector, then everything gets converted into character. All right. And that's what happens in your matrix as well. So everything is in double quotes. All the elements are characters. All right. So mode of, we saw for vectors also, mode is basically what type of data is stored. So in M we had numbers, in R we have characters, in S also we have characters. Attributes is a slightly more complicated than just dimensions, but you can see, so an object, so basically data objects, as we'll see more and more in the next few weeks, data objects can have multiple attributes. One of the attributes is dimension. Okay, so dimension is 3, 2. There could be more attributes. Right now, this matrix does not have any more attributes, but you can forget that for now. But yeah, just basically this is it's just some common functions that are there. Okay. Okay, so this, I'm not sure if this was a part of the course, but anyway, we saw some functions last time, which was is character as character, is numeric as numeric, right? So very similar to that, we have also something called is matrix as matrix. So is matrix is to check whether something is a matrix or not. So if I check is matrix P, and P was actually a matrix, so it's going to give me true. If I do is matrix X, X was not a matrix, right? It was a vector, so it's going to give me false. Now, as matrix converts something to a vector, to a matrix, right? So now here, what it did was it did convert it into a column sort of a matrix, right? Because if you remember, the default when you're writing a matrix is by row is false. So it's by column. So it just says, okay, I'll fill everything as a column. So it's making a column matrix. So basically what you're doing is you're writing n row is equal to as many elements you have in the vector. N call is 1 and by row stays false. That's what's happening here. Okay. And because if you write dimensions of x, so x did not have any dimensions as itself. X has a length, but there's no dimensions to it. But when you say dimensions of the matrix X, so that's 6 comma 1, because now you have 6 rows and just one column. Yeah. So again, the data is still the same. X is still those 6 elements. But whether you write it as a vector or whether you write it as a matrix, sometimes you can do different calculations, or you can do some different operations on it. Okay. But all right. So that's something. So that's about the revision. We still have some time. So if you're up for it, I have some practice questions that you can take a look at. And how they're very similar to how you have your questions in the assignment. I would like to tell you something about the assignment though. So questions like this, you can definitely directly feed them into R and get the answer, which is a good thing to do. However, in the final exam, so if any of you are appearing for that exam, you would not have access to R or R Studio during the exam. So if a question like this comes up, you'll have to do it manually. The idea is that you've understood how R is going to understand these questions. So how is R going to calculate? So what you can try, if not for all, but at least for some questions, try solving them on your own. They can be a bit complicated, so you can choose some of the easier ones. Try to solve this manually, and then double check by typing it into R. Okay. So again, I'm not very sure if there's a lot of point into calculating this manually right now, but what you can maybe what we can figure out right now is what's going to be solved first. So you have a vector here. I can have my pen. Okay, so there are we have 5 vectors in this question. And so basically we have 4 operations, right? This one, this one, this one, and this one. So out of these 4 operations, which one is going to be solved first? So there's a division, there's a multiplication, there's a power, and there's a minus. Again, board mass.
Yes. Ma'am, maybe this C 2132 square
Not square, power.
12233.
Yes,
Power,
yes,
yeah.
yes,
So
yes,
power, first we'll solve this
yes.
one.
So this is going to be solved first. So you get what is going to be the length. So what the output is going to be like of just this thing.
2 plus 2 comma 2
Okay.
comma 9. No, not 9. 27
Perfect.
comma
Okay.
8.
Okay, cool. So let's actually try and solve this. Okay. So we first have 2 to the power 1, 1 to the power 2, 3 to the power 3, and 2 to the power 3, right? So we get 2, comma 1, comma 27, comma 8.
8, yeah.
Yes, okay, perfect. Then what are we going to solve?
Then division.
Then division. So it's going to be these 2 things. So that's 1 by 1, 2 by 2, 3 by 2, 4 by 4, right? So that's going to be 1, comma 1, comma 1.5, comma 1. And then
This vector multiply with C,
yes,
this one.
2,
Yeah.
127, 8. So here we get 2, comma 1. Okay. I don't know.
27. 27 into
27
1.
plus half of 27, which is
30.
13.5. So 40.0, right?
40.5.
Yeah, 40.5. So that and 8. And then we subtract the last one. So 2, 2, 32, 5. Okay. So then we get 2, minus 1. Oh, sorry,
No, ma'am,
0.
0.
Yep,
Yeah.
0, minus 1, 8.5, 3.
Yeah.
So the second option is correct, right? So
Yeah.
questions like this. So you did not actually need R to solve this. You solved it the way R would. So you've understood how you write something in R, but you can solve this manually, right? So it can be a bit time consuming, but it's okay. Okay. So this one's a little more complicated. Do you want to give this a try as well? Okay, let's try a different color. Okay. So again, we have some complicated things happening. Okay. So this is one set, this is another set, this is another set, and this is another set. Okay. So let's try to solve. So we can all agree that we are going to solve the first 4 sets together, and then we'll see which ordering we need to combine the 4 sets, right? So first of all, let's talk about this one first. Okay. So what do I solve first here? So I have round, I have prod, and I have this power. Which one goes first?
First inside power.
Power, right? So I'll have 1, 2, 1, 2, and to the power 1 and 2. So 1, 2, 1, 2, right? So I'm going to get 1, 4, 1, 4. And then I say product. So product means I'm just going to multiply everything. So I'm going to get 16 here, right? And then I say round it off. Now there's nothing to
16.
round off. So
Yeah.
it still says 16. Easy, right? Okay. Let's solve this one next. So here also, it's 1 to the power 2 to the power 3, then 1 to the power 2, then 2 to the power 3. So that's 1, 8, 1, 8. Here, I need to sum these up. So I still get 16 here, right? Let me know if I'm doing
18,
something.
18.
18. Yeah.
Oh, sorry. Oh, yes, correct. Good. Yes, 18. Good. I multiplied half of it and I added the other half. Sorry. Okay. Okay. Then we have this one. So again, 1, 2, 1, 2. This is to the power 1, 2, 3, and 7. That's 1, 4, 8. To the power 7. Is it 32? No, 4, 4. No, it's not. Yeah. 4, 4, 4, 2. 16 and 8. 8, 4, 128. Right? Can any of you confirm if this is correct?
Yes, ma'am.
Yeah. Okay. And then I need to product these as well. Yeah. Okay. So I need to, here you can use a calculator. So you would have access to calculators in the exam. So it's basically 4 into 8 into 128. So that's 4096. Okay. And then, let's take black. Okay. Then we have this one. So 5, 6, 7, and 8. Okay, now we're dealing with larger numbers.
216.
216, 49, and what is 64 into 8? 512. Okay. Yep. And then it says ceiling. Okay. So here, now the difference in all of the others was in this one, because of the product function, I was getting one answer. Here, because of sum, also one element. Here, because of product, again, one element. Here, there's nothing like that. So when I do a ceiling, which is the next highest integer, the number still stays the same, right? So I have a vector. So I'm dealing with scalars and vectors here. Now tell me, which of the four things I combine first? So I have a multiplication, I have addition and addition. So I multiply first, right? Yep.
Yes.
So I'll get 288 from these two. And then I need to add 4096 and then add this vector. So this can happen in any order. But what we can do is we can add 288 and 4096. So I'm going to get wait. Okay,
Four,
yep.
3.
4384.
Yeah.
And then we're going to add this thing to each of them. So anyway, the answer does not exist here. I think I might have done something wrong somewhere, because earlier I had calculated and for something else I was getting A as the answer. But okay, what we can do is we can just type it into R and double check if what we are getting is correct, because from what we've solved it should be none of these. But I'm pretty sure the answer is A here. So let's just check. Okay. I hope the screen is still a bit visible. So let's try solving each of them. So round prod C 1, 2, 1, 2 to the power. So that's 16, so that's correct. Then we have some C, that's 1, 2, 2 to the power 2, 3. So that's 18, that's also correct. Product 1, 2. And so that's, okay, what did we do wrong? This is 1 to the power 3. So this is just 1. Okay. So this is just 1, right? So it's just going to be 4 into 128 then. So this instead becomes 512, right? And now 512 plus 288.
800 and then 25, 825.
Yes, right? And this is 800. So then we add 800 to each of them, and then the first option is correct. Okay, so yeah, so it's just basic maths error, but you see that how R is helping us. Definitely, you won't do these errors in R. What errors you can do in R is mess up the value, mess up the positioning of the brackets, right? So because you can see there are, of course, as many brackets are open, they all have to close. But where you close each bracket, that's important. Okay. Alrighty. Okay. Okay, next. So which of the following is the value of x2 when the following commands are executed? Okay, just in the interest of time, we're not solving it right now. The correct answer is one of A, B, and C. You will be able to solve it. If we get time, we'll come back to it. But again, it's just for your practice. Okay. Okay. Now this question looks very complicated. It asks you which of the following commands will give you a result without a warning. You don't have to run any of them, but just remember, when do you get a warning? So here we are dealing with multiple vectors. When you are dealing with two vectors which have the same length, you don't get a warning. When you're dealing with vectors which have different lengths, but one is a multiple of the other, you also don't get a warning. You get a warning when the two lengths are not multiples of each other, right? So in the first case, this is a 3. 3 is not a multiple of 4, or 4 is not a multiple of 3. B looks good. C also has this 3-element vector, and D also has the 3-element vector, right? So B is going to be the answer. Yep. And one of you rightly mentioned that. Okay. Again, very similar question, but this is, I think it's quicker, so we can try this. Again, which one are we going to solve first? So this, and this. There are 4 things to solve. So there's multiplication, power, multiplication. Just like the previous question, we'll go for the power first. Yep. Okay. So, okay, now keep in mind this minus sign that we have. Okay, we'll use it next. But for now, let's just consider that. I mean, it's again the same thing. Either you put a minus sign later, or you already bring the minus sign inside and have each element as a negative value. Either way is okay. So what we can do is we can already call this a negative number, right? So we'll just have this instead. And then it's to the power -1, -2, 1, and 2. Now you remember how minus power is dealt? It's 1 upon something. So it's -1 becomes 1 upon -1 to the power 1. So it's basically -1. This one we can just see, so 2 to the power -2. That's 1 upon 2 to the power 2. So that's 1 upon 4. And that's 0.25. Okay. And this is 1 and this is 4. And this one we can have, so it's 1, 2, 1, 2. And this one also we can write as 1, 2, 1, and 2. So basically now we want to multiply these 4 numbers element wise. So it's going to be 1, -1, -1. That's 1. 2, 0.25, and -2. So that's -1. Yeah, 2 into, yeah, that's -1. Correct, sorry. And then you have 1, 1, 1, so that's 1 again. And you have 2, 4, 2, so that's 16. We don't have the answer here. Okay. And never mind. This is the answer. Okay. I might have done something here. It's supposed to be B. We've not done it wrong, right? Second has error. Oh, this one.
Yeah, -2 because
Yes.
this will be minus, then plus.
Yep. Perfect. Okay. Good. So yeah. So it's the first answer.
Yeah.
Yeah. Okay. All right. Great. This should be simple. So what command are you going to what command are you going to write to get this matrix? So the differences are whether you have written matrix or mat, and whether by row is true or false. Right? So you have to write full matrix, and yeah, so it's this one. Okay. Which of the commands is to obtain the third column and the first row? But we're doing it separately. So these are 2 separate questions, not one single answer. You want to obtain third column, and you, in a different setup, you also want to obtain first row. See, right? Okay, because this, when you're writing after the comma, you are talking about the column, and before the comma, you're talking about the row. In this, I think, yeah, this is the last question. If you write dimensions of X and dimension of Y for the matrices X and Y, what output do you get? So, yeah. So that two.
I don't know.
Okay.
E.
A, yes. Because this is your n row, and this is n col, and this is also n row, and this is
Okay,
n col, always, right? So these are positional arguments. You always have row first, column next. So this is a 30 by 2 matrix, and this is a 2 by 30 matrix. By row argument, it doesn't matter in terms of the dimensions of the matrix, right? It's just how you're filling the values. But filling has no impact on what the dimensions are, right? So yes, so A is the correct answer here. Okay, cool. So that's for this week. Do you have any questions or doubts from the assignments of the last 2 weeks? So every Wednesday now you have the assignment submission, and on the Thursday after that you'll get the solution for that. So if you have any doubts from there, you can let me know. Yeah, fine. It's just okay. I'm just stopping my sharing for a bit. Yeah, so if you have any doubts from those, we can discuss that. Otherwise, that's the end of the session.
To write multiple lines of program, please explain.
Say that again.
How to write multiple lines of program? Same program is written in 2-3 lines. It is
Oh,
giving
yes.
error message.
Okay. Yes. Right. Okay. So what we can do. Okay, just give me one more second. Share. Okay, so let's say, so let's say I've selected the whole thing here. Let's say from here. So let me just double confirm with you. If I have a long command and I've run the whole thing, and does it stop somewhere in between, or you already realize that it's an error? What's happening?
It's not going to the next line, madam. When it is not, when I'm clicking to the next line, it's not taking the next line.
Okay. Do you want to share your screen and show us maybe?
No, I can request one thing. This assignment week, assignment 3, you cannot solve that, but there are so many programs like that. Just you can show how to write that one program. Not result. I don't want the result. How to write that. Assignment 3.
You will just have to type this, like you just typed this one here. This thing.
Now, while ending that line, I would put some brackets or how to proceed for the next line.
Oh, I get it. Oh, I see. Okay. So what you can do is you can just put, so maybe some bracket is incorrect. So you can just try closing some brackets. You just count how many brackets are opened and you need to close as many brackets. So I'll give you an example. Let's say, okay. So sum, and let's say I write 1, 2, 3. Let's say this is what I've written and I press enter. Now it gives me this plus sign. This is what's happening, right?
Yes, I'm getting
so
like
now,
this.
Yes. So now what's happening here? You had 2 opening brackets, but only 1 closing bracket. So R says that you've not yet completed your statement. So you still have scope to complete your line. So what I can do is I can close the bracket. And then when I press enter, the whole thing is counted as 1. And I get the answer. And then I get this greater than symbol also. So what is happening here? I can understand it's complicated when you have so many brackets to deal with. But what you can do is just count if you've closed all the brackets. So which is why try typing it in the script first. And then what you happens is, if you see, whenever you are clicking, whenever your cursor is at a bracket, the closing bracket gets highlighted. Or whenever your cursor is at a closing bracket, the opening brackets gets highlighted. So suppose if I have written something like this here, so you see this bracket is highlighted, but there's nothing corresponding. And R was also going to give you errors that something is missing here, something is unmatched, something doesn't make sense. So you will save on that problem. Give it a try.
When I'm starting the next line, shall I start with the assignment operator, either division or multiplication? It is accepted. First line I'm closing with brackets.
Yes.
When I'm starting the next line, I'm starting with the division operator. I'm giving it. So it's accepted.
Yes. So because the thing is, that it still considers that the statement is incomplete. So it doesn't go to the next.
It must end with bracket. Shall I take like that?
Yes.
It must end with bracket.
Yep. Number of opening brackets and number of closing brackets should be the same. That's the bottom line. So what you can also do, if it's okay, so you know that there is a discussion forum for the course, right? This Q&A option here. So you can put a screenshot there, and then we can take a look at what the error is. But I think if you try and see the bracket thing, it should work. Okay, give it a try. You should be able to solve it. Okay, so I hope that's it for now. Okay, so thank you for joining, and do remember to submit your assignments on the coming Wednesday. So that's 14th August, and then on 16th we'll have our next class. And in case you still have some doubts, there will be another session for this week on Tuesday. You can also join that if you have any confusion. Yep. Okay. All right. Thanks for joining. I'll close the meeting now.